Uh, Good evening, everyone. This is Sharat Baswanda, and this recording is a part of submission for the project what I did for in the fulfillment of CISE 66551. It's a biometric authentication system project which was taught by Professor Majid Chalak as a part of summer 2018. So, in this project, what I have done is like I have identified and developed Iris biometric authentication system. So, let's go ahead with the introduction. Introduction. So, introduction basically like what is biometrics? Biometrics is like a unique way of identifying every human being. When you consider like there are a lot of other biometrics which are unique to each and every humans in the entire world, like fingerprint, voice, retina, walking pattern, so on and so forth. What does biometric authentication mean? So biometric authentication means that involving a biometric system which authenticates and authorizes the person based on the unique biometrics which he or she possesses, and it will get authorized whether he or she will have access to the particular system or an application. So that's basically a biometric authentication means. So in this project, right, we're gonna talk about the overview of the biometric system and also detailed overview of iris scanning system. So going to the next presentation, going to the next paragraph. So basic structure of a biometric system. As you can see in this particular diagram shows the basic structure of a biometric system, where the sensors collects a lot of data. It pre-processes. It does a lot of pre-processing, and it extracts the particular feature. For example, the unique line pattern in the fingerprints or unique retina patterns in the iris scanner, so on and so forth, and it generates a template so that it gets stored in the database. So when an let's say when it matches a system, or when it sees an image of a retina or a fingerprint, something like that, it gets it gets matched with the stored templates that is in the database, and which, if it is a closest match like 99% or 100% match, then it goes into then it authenticates and authorizes the application system. So that's the basic structure of flow during in a biometric system. So in a biometric system, as mentioned, there are two phases, right? One is an enrollment phase and one is a matching phase. In enrollment phase, what happens is that the feature extractor, once it is extracted from after pre-processing the data collected by the sensors, it does a template generate. It generates the templates, and it stores those templates in its own database. That's called as an enrollment. Matching is nothing but when you see an image of an object, after it does its all pre-processing and scanning, that particular feature extracted is getting matched with all the stored templates in the database, and whichever is the closest match, it will output that data, saying that this particular fingerprint or this particular iris image matches to this and this, so on and so forth. And this can be incorporated in the authentication and authorizing the application or system. Now, as I mentioned, same in the enrollment phase, what happens is a small diagram. So in an enrollment phase, what happens is that the name, print or fingerprint or something like that, it goes to a quality checker, and then the feature is getting extracted and it stores in the DB. That is what the enrollment phase is. In a verification or a matching phase, what happens is that that particular data, if let's say if I put a data, or if I give the image of one particular data, after doing the feature extracting, and after it extracts the feature, it identifies the templates in the system DB and it does the matching process. And if it is true, it authenticates and authorizes. If it is false, it says that this particular feature or this particular image is not stored in the DB or something like that. Going on to the classification of biometrics, as you can see in this diagram, there are like physiological biometrics and behavioral biometrics. Physiological biometrics deals like iris, finger, facial recognition, DNA, Those are all physiological. Whereas behavioral deals with the signature pattern, the speech, how he's gonna speech, and what are the keystrokes, what is his walking style. Those all deal comes under behavioral biometrics. Coming to, this is the introduction of what is biometrics and what is biometric authentication system. Now coming to the specific particular project, iris recognition system. So I have incorporated, I was interested in working on iris recognition system. One of the main reason why this interests me is that there are a lot of technological advancements that's happening in the field of iris recognition. It is if this particular system is calibrated and configured properly, the percentage of match will be 100%, and it will act like a first line of defense for any intruders when it is incorporated in the system. So, and also this is like a foolproof method because every iris is unique, and it is very there are different ways of doing a feature extraction from the iris, so on and so forth. And for example, Samsung in particular is doing little pioneering in this particular area by incorporating iris recognition system in their software, in their mobile system. So this way, instead of doing a fingerprint unlock, so it unlocks the phone based on the iris scanner, and that happens instantaneously, within a milliseconds. So they are doing a lot of research, and they are pioneering in the field of iris recognition system. So coming to, as you can see in this diagram, so this is a structure of a human eye, where there is a collarate, a pupil, iris, sclera, and then eyelids. So these comprises of all the structures present in the human eye. So when it comes to iris detection system stages, as you can see in this diagram, what happens is that once the iris image is acquisition, the acquisition is the what it's getting collected, and it does localization, pre-processing. In this pre-processing, what it does is like it does a pupil boundary detection and iris boundary detection. So as you can see in the above diagram, what is a pupil and what is the iris, that does like that boundary detection it identifies, and it does a normalization of that particular image, and the feature processing, it does a feature extraction or feature encoding and stores it in a database. So if a matching iris image is getting presented to the system, again it does the same processing, and it matches against the DB whether this particular image is being stored in the DB or not. If it matches, then it authenticates the system, and if it doesn't matches, it rejects the image, right? So basically, this particular and all these all these stages, right? It should happen in a real-time environment within an instant, and you cannot, humans cannot afford to waste like the 10 minutes of time for it to match against its own database and authenticating and authorizing the system. So basically, all these things has to be instant, and the way the pupil boundary detection or the different kinds of algorithms that is used in pre-processing and normalization, it has to be performance tested, and the performance of this under heavy load should be well within the SLA, predefined SLA. If I as a company are defining the SLA like within 10 milliseconds it has to do it, so that means that within 10 milliseconds it has to do the pre-processing, normalization, store it in the DB, and match the image with the DB. So all these things has to happen within 10 milliseconds. So it all depends on how what algorithms or what kind of techniques is being used. So same thing. As you can see here, the iris detection system consists of 3 stages: enrollment process, normalization process, and the matching process. Right? It's the same thing what I have explained here. So in this, to achieve this, what I have done is like Huff transformation technique I have used, and this is that I will go over the code match up what I did. So, but basically, let's open the readme.txt. Okay, it doesn't matter. So okay, in this huff transformation dot p, actually let's go over the code. Actually, you know what? Let's go. Sorry about that. So in this program, right, what I have done is the circle huff transform is being implemented by voting in the huff parameter space. The image is smoothened using Gaussian filter to eliminate any unwanted noise, and then the edges are detected in the image using Laplace of Gaussian. This provides the basic outline in the image, and at each point of the image, voting of all the possible circles is performed in the huff space. Right? The local maxima in the huff space gives the area of the circles, and the threshold is used to identify the qualifying local maximas. The implementation requires identifying the optimal threshold values for edge detection and local maximas. This is done iteratively by scanning through the threshold space. Once we implement this huff transform.py, what we are able to achieve is that, so this is the image of an eye. What it does is it creates an edge map, and this is the phases of how it gets how it uses huff transformation technique to get those proper lines. This is the pupil and this is the iris, right? So it properly gets the what is the area of the iris and what is the area of the pupil. Now, normalization. So once the iris image is extracted, right, next is to convert the image of iris so that it has some fixed directions. Because it's a circular image, we have to convert it into a why it's the why we have to convert it into fixed direction is that because the pupil present in the eye, it keeps stretching and shrinking based on the pupil dilation or because of the heavy light source. To achieve this fixed dimension in order to be compared with the stored images of the iris, there is called as a Dogman's rubber sheet model, which is being used. The Dogman rubber sheet model, what it basically does is that it helps in getting the coordinates by mapping the line image coordinates obtained by the huff transformation to a rectangular sheet or a polar coordinate system. So as you can see in the below, so this particular image, the first particular image, the pupil is very big when compared to the second image. So it has to identify what is actually the pupil and what actually is the iris scanner. So which can be seen here. By applying this thing, we will get the Dogman rubber sheet, which gets matched when you put the images in the when you give an image of an iris, it gets matched against the stored templates in the database, and then it does whether it's matches or it rejects. So this is the iris scanner system, which I am very much interested in working for as a part of 699 project, and this is a little bit interesting because there are a lot of shortcomings in the huff transformation and the Dogman's the rubber sheet model. So all these techniques has its own flaws, right? So that can be a problem statement, and there will be a workaround for these shortcomings of these techniques, and that can be a problem statement for the CISC 699 course, which I am very much interested to do it, and this has been selected as one of my problem statement questions along with others, then I will have to evaluate what is the best project to work on for 699 project. But definitely this is one of the problem solving questions which I have in my repository. So coming to the conclusion, what happens is that in this advanced technological era, biometric authentication and authorization is getting implemented in most of the systems, and if these models are configured and modeled correctly, they can act as a first line of defense against any intruders. There has been many advancements in the iris recognition technology, and it's paving its own way in securing the systems. This advancements has also led to dominate against the other biometric systems like fingerprint, etc. And I truly believe that our iris recognition software, iris recognition system will be implemented on all the systems once some of the shortcomings are being identified and the algorithm is fine-tuned in such a way that it meets an SLA. Now, going over the code, as you can see, this is a pie chart. What I have, what is the code? This is the half transformation.py. To run this program, it requires the following packages to be involved. I have included NumPy, Matplotlib, and SciPy. These are the imports what I have done, and similarly, a circle half transformation, like I said, is implemented by voting in the half parameter space. The image is smoothened using the Gaussian filter to eliminate any unwanted noise, and the edges are detected in the image by using Laplace-of-Law Gaussian. This provides a basic outline in the image, and at each point, the voting for all the possible circles is performed in the half space. That's what it is done here. So as a part of this, I didn't give the image of the eye. So I took one image saying that. So this is the image. It's just an image of a lot of coins in it. So once I enter this, pass this image into the half transformation, this is the output I got. So it recognizes the outline of each and every circles. Similarly, if you present an image of a retina, it will identify what is a pupil image, what is the what is the iris space, so on and so forth. And there have been some of the issues in this code which I am getting a lot of errors, which I need a little bit more time to debug this thing, because once I did the once I try to train the system by adding a lot of input images, I'm facing a lot of code issue, but I'm pretty sure that for a 699 project, if I decide to work on this, I can easily make this program work, and I can. It is possible to develop an intelligent iris scanner system. So I think these are the references what I have considered you when I'm writing this project. Yeah, that's all this project. Thank you very much. See you. Bye.